So today we're going to start a new series on coordinate geometry. So this video and series of videos will be enough to prepare for coordinate geometry for JEE Advanced and JEE Main and also for class 11. So we are going to start from the very basic, that's from coordinate axis and all the basic formulas like distance formula, angles, centroid of a triangle and stuff like that. And slowly we are going to move forward onto straight lines, circles, ellipse, parabolas, hyperbolas. And also in each chapter, what I'm going to do is I'm going to start from very basic, but then I'm also going to introduce a lot of examples, both at boards level and also at JEE Mains and JEE Advanced level. But then again, this can also be used to prepare for coordinate geometry for other examinations like ISI, CMI, and related examinations. Okay, so let's begin from the very basics. This is called a coordinate axis plane. Okay, so this is what we will call a Cartesian coordinate plane, where this x-axis is basically this horizontal line that goes from left to right on your screen, and the y-axis is a vertical line that goes from up to down on your screen. The positive direction in y-axis is above, and for x-axis it is right hand side, like this. On the left hand side, it is called x prime, which is the negative x-axis, and on the downside, it is the negative y-axis. The intersection of axes is called origin, and it is written as O. With notice this part, this is called coordinate of a point. I have written 0, comma 0 in onto the right of O, which denotes the location of the point O. This is our reference point. So in coordinate geometry, every point is characterized by a special pair of numbers in 2D coordinate geometry, of course, which are called the coordinates of that points. Okay, so how are we basically going to evaluate? Like let's say we have a point P and x comma y is its coordinate. So how do you determine this x and y here, and what do they actually mean? Okay, so let's break it down. Point P with coordinates x and y, the first one would always mean the x coordinate, and the second number after the comma would mean the y coordinate. Now, x here would mean, we will assume x and y are positive here. X would mean from the origin you go a distance of x units to the right. So precisely, if you were to draw a perpendicular down directly with and making an angle 90 degree onto the x-axis and name this point as M, the distance OM should be equals to the x coordinate of the point P, because the origin is at 0 and M is at x comma 0. Now coordinate of M should be x comma 0, because as you can see, height of M is nothing. It's basically 0, because this is where the origin is and it is in the same height as the origin. So if you were to go up or down, only then would the y coordinate change. Similarly, the comma y here for P would also mean that it is at a height of y units from the origin in the positive y direction, which would also mean that MP is equals to y, where M is this, P is this. Now we can also connect O and P, and this OP here would, it is basically the distance of the point from the origin. So it is distance of P from origin. So OP is the distance from the origin, and we can find this out since OMP is a right angle triangle. You can see since angle OMP is 90 degree, this is a right angle triangle. And what we can do in a right angle triangle, we can always apply the Pythagoras theorem. So applying the Pythagoras theorem, we have OP square, which is the hypotenuse, should be equals to OM squared plus MP squared. Now, OP squared is what we needed. So we basically need OP here. So OP should be equal to square root of OM square plus MP square. Now we already have figured out that OM is basically X, where X is the coordinate, X coordinate of the point P, and MP is Y. Thus, the distance from the origin is nothing but X square plus Y squared. Okay, great. Now, a few more points about axis would be better here, because it would also help us to understand what quadrants are. Again, we have a quadrant system where x-axis and we have an y-axis, a negative y-axis, and a negative x-axis. Similarly, the intersection would be termed as origin or 0, comma 0. Any point. So you can see the screen has been divided into four parts whenever I draw a coordinate plane like this. This right hand top part is called the first quadrant. This is called the second quadrant. This is called the third quadrant, and this is called the fourth quadrant. Now, each of these quadrants have some specialities. Like for the first quadrant, every point in the first quadrant, like there are infinitely many points that reside in the first quadrant, right? Like any point which is to the right of the y-axis and above the x-axis. These points always have the form plus comma plus. That is, the points here have coordinates which are both positive. Because all the points are basically to the right of the origin, that means they have a positive x quantity as coordinate, and they're also above the origin, which means they have a positive y coordinate. For the second quadrant, now they are onto the left of the origin and above the origin, right? So since they're on the left of the origin, their x coordinate is negative, because on the left of the origin, all points have negative x coordinate. And but then again, it is also above the origin, so their y coordinates remains the same and it's positive. For the third quadrant, both of them are negative, since you can see that it is below the origin and to the left of the origin. And for the fourth quadrant, you have negative y-axis because it is below the origin, but positive x-axis, x coordinate. So plus comma minus. So these are the forms the points are going to take in this different quadrant. And each of these quadrants span an angle of 90 degree each. And in total, they make up 360 degree. I think that was clear. Okay. Now, we understand how these points are acting here. So we will also try and understand a different way to locate points. So this is the Cartesian form where you locate a point using its distance in terms of x-axis and y-axis from the origin. That is x and y. There is another way to find out the location of a point, or make a general method to locate any point, which is called the polar coordinate. So we learned the Cartesian coordinates. We are now going to understand polar coordinates in very detail so that you do not forget it and you can apply it easily to any formula. And we're also going to learn how to interchange between them. As usual, we will draw our x-axis and y-axis. This would be y prime and this would be x prime. And let's denote that there is a point P of coordinates x comma y. Now, this is our origin O, which has the coordinate 0 comma 0. Now, if we were to connect OP and then do the similar thing we did in the previous illustration, where PM is perpendicular to the x-axis OX, and we know that OM is equals to x, then PM is equals to y, and we also know that OP is equals to root over of x square plus y square, as from the Pythagoras theorem, which we have just found out. Distance of any point from the origin is square root of its coordinate, sum of the coordinates squared. Correct. In polar coordinates, we determine a point using the length using the distance of this point from the origin and the angle this line makes with the positive x-axis. So there are two parameters in polar coordinates. So in Cartesian coordinates, there were two parameters, x and y. In polar coordinates, there are two parameters, r and theta. So r is the distance of this particular point, whichever point we are trying to reference, from the origin, and the theta is the angle that line which joins the origin and the point makes with the positive x-axis. We will understand what it means right now. Okay, let's say this is the point x comma y and we want to write its corresponding polar coordinates, which is not x comma y. We have to write it in terms of r and theta. Okay. First, we will first let OP equals to r, which is the distance from the origin. This is very simple. So basically OP equals to r, which is in turn equals to x square plus y square. Now, in the right angle triangle OPM, observe that cos theta is equals to OM by OP. Cos theta is equals to OM by OP, right? Similarly, sin theta should be equals to MP by OP. From this you can get OM is equals to OP cos theta, and you can also get MP is equals to OP sin theta. Okay. Now we have established that OM is X and PM is Y. So from that we can write X is equals to, and then again we have denoted OP as a standard distance R from the origin. X is equals to R cos theta, correct? Because you can understand OM is X, OP is R. Similarly, MP is Y and OP is R again, which gives us another set of equations, Y equals to R sin theta. Now we have already gotten the value of R to write in our polar coordinates in terms of the X and Y's. We also need the value of theta. If you divide these two equations, you get Y by X equals to R sin theta upon R cos theta. In a little while, we are going to do an example which will basically clear why this is useful and how to do problems of this kind. And this you can understand is tan theta. Now, if y by x is tan theta, then using the inverse tan, we can write theta equals to tan inverse of y by x. As simple as that. And thus we have found out our two quantities r and theta. So for a corresponding x and y coordinate in Cartesian coordinate, the corresponding polar coordinate would be r comma theta, where r and theta can be derived from this x and y's as follows, where r is root over of x squared plus y squared and theta is tan inverse of x y by x. This would be the derivations. Great. Okay. So now let's delve into a few examples. First, let's find out the basic example. Let's say we have a point 2 comma 2 and we want to transform this point into a polar coordinate. This is a Cartesian point and we want to transform it into a polar coordinate. So obviously our x is the point 2 and our y is 2, right? In terms of x and y. Now, what do we know? We need to find r and theta in order to transform it into a polar coordinate. So what is r? R is simply x square plus y square, as you know, and x square and y square are 2 square and 2 square. So 2 square plus 2 square, which is 4 plus 4, 8. So this is root 8. We can also simplify this and write this as 2 root 2. Now, what's theta? Theta was tan inverse y by x, and this would give you tan inverse. Now, since y and x are both 2, you will get tan inverse of 1. And you remember tan of 45 degrees 1, so tan inverse of 1 should be pi by 4. So our corresponding polar coordinates for 2 comma 2 is 2 root 2 comma pi by 4. So these are the same points. One is in Cartesian coordinate and one is in polar coordinate. And the intuition behind polar coordinate is you start from the origin and you go and you first fix an angle of pi by 4 with the positive x-axis, and then you go a distance along that direction equal to r, which is this line should be 2 root 2, the length of this line up to this point. And wherever you reach, that is your required point, which should be 2 comma 2 in the Cartesian coordinate. When you reach that point, you can see that its distance horizontally from the origin should be 2 units, and its height horizontally from the origin, vertically from the origin should also be 2 units. So these are the changes between two different coordinate systems we have, and we are going to use them frequently. Great. Okay. So let's do a good example actually, where we would require to do some trigonometry, and we would be forced to use some concepts. So let's say we have an equation r square equals to a square cos of 2 theta, and this is an equation in polar coordinate. It's a polar equation of some graph. There is some graph in Cartesian plane which has a polar equation r square equals to a square whole into cos of 2 theta. We want to find its Cartesian equation. And what do I mean when I say Cartesian equation? I only mean that the equation should not have r and theta, rather it should have x and y as the x coordinate and the y coordinate of the point. So that when we want to graph this point, we can use the x and y coordinates. But how do we transform? We will use the same rules. We know that r is equals to root over x square plus y square. And we know that theta is equals to tan inverse of y by x. And from this too, we can also find out that r square then would be equal to x square plus y square. And then tan of theta should be equals to y by x, right? Because this was the initial equation from which theta equals to tan inverse of y by x was derived in the first place. So we will use this to transform this equation into an equation containing x and y only and not r and theta. A is a constant, so A can stay. So let's put the value of r square first. It will give you x squared plus y squared equals to a squared. Now cos 2 theta can be written in trigonometry. You should learn this formula: 1 minus tan square theta by 1 plus tan square theta. And using this, now we are almost at the end of this problem because tan square theta can be represented as y square upon x square. So x square plus y square equals to a squared whole into 1 minus y square by x square divided by 1 plus y square by x square. And if you simplify this, you get x square plus y square equals to a square multiplied by x square minus y square divided by x square plus y square. And therefore, the equation for the graph in Cartesian plane should be x square plus y square whole square by cross multiplying this x square plus y square in the denominator and taking it to the left hand side equals to a whole into x square minus y squared. This is the required equation in Cartesian plane. So these questions are not really tough, but then again, you have to be a little resilient with the formulas that you're going to use. Okay, now let's learn about distance formula. So this is the first formula that is very important in this whole list because everything else was basic, but this is something you're going to use throughout your coordinate geometry problems, any problem you may face. So distance formula is something that builds up everything else. Okay, so let P1, x1, comma y1 and P2, x2, comma y2 be 2 points and we want to find out the distance between these 2 points. Let's denote dp1, comma p2 and the distance is found as follows. We simply subtract, take the difference of the x coordinates and square it. That is x1 minus x2 whole square. And the order in which you do it does not matter because you're ultimately doing a perfect square. So whatever quantity you have inside will always come out as positive. Similarly, you add it with the difference of the y coordinates. The proof of this is basic and I will leave it to you. You can do it using same Pythagoras theorem application by plotting two different points in an axis plane like this, P1 and P2, and then trying and finding out this distance using the origin, of course. Okay, so this is the distance formula. It's a very straightforward formula, but you would be using it a lot. Okay, so let's try and use this formula. Example. So let's say for a greater than 0, find the distance between the points a cos alpha, a sin alpha, this is point 1, and a cos beta, a sin beta. We need to find the distance between these 2 points. So for sake of simplicity, always name the points as some things. So let's say A is our point where A cos alpha and A sin alpha is our point A, and B is another point whose coordinates are A cos beta and A sin beta. Then AB should be equals to A cos alpha minus A cos beta whole square plus A sin alpha minus A sin beta whole square. Now, what we can do is we can take a common from inside and what we will get is this. We will get a squared whole into cos alpha minus cos beta whole squared plus a squared whole into sin alpha minus sin beta whole squared. And if you were to take a square common out of the whole thing and then apply square root to it, you should get mod a. But then again, a is positive, so mod a we do not need. We only need a here, right? Because a was given as positive. So thing is, root over of a square is basically mod a. So root is for any real value of a. So since we already know that a greater than 0, this automatically turns to a, which is what I have done here. Okay. And now inside we have cos alpha minus cos beta whole square plus sin alpha minus sin beta whole square. We can break it down. And we will get a bunch of terms like this: cos square alpha plus cos square beta plus sine square alpha plus sine square beta. And we'll also get the two AB terms like this: minus 2 cos alpha cos beta minus 2 sine alpha sine beta. This would then mean, now cos square alpha and sine square alpha would add up to get you a 1, which is the identity. And then again, sine square beta and cos square beta will also give you a 1. Those ones will add up to a 2. And you can also take the 2 common from here, and you can see that inside we have cos alpha cos beta plus sine alpha sine beta. Now, what we can do is, because this is a formula for cos of alpha minus beta, we can write a into root over 2 times 1 minus cos of alpha minus beta. And now using the half angle formulas, we can write that therefore the distance between the points AB, or the length of the line segment AB, is nothing but a into root over of 2 times. Now 1 minus cos theta can be written as 2 sine squared theta by 2. So the formula we are going to use is 1 minus cos theta is 2 sine squared of theta by 2, where theta is the angle involved in this equation. Now here our theta is basically alpha minus beta, so we will have 2 sine squared of alpha minus beta by 2. Now 2 into 2, 4, root 4 is 2, so we have 2a outside into root over of sine squared of alpha minus beta by 2. And as I have explained before, root over of a square gives you mod a. So root over of sine squared should give you mod sine, right? So 2a sine of alpha minus beta by 2. This is our required distance, and the mod is important because the distance AB cannot be negative. So even if sine of alpha minus beta by 2 is a negative quantity, the modulus operator will make sure that it's positive, and thus the distance AB is found. And this is the distance between the 2 points. Now we can do another example here with the distance formula to get a bit comfortable with it. Let's say point x comma y is equidistant. Is equidistant from 6 comma minus 1 and 2 comma 3. Prove that x minus y is equals to 3. So it's a fairly simple and straightforward statement. It says that the point x comma y is equidistant from both the points 6 comma minus 1 and 2 comma 3. You have to prove that x minus y is equal to 3. Okay. Again, for sake of simplicity, always name the points. So P is x comma y, then A is 6 comma minus 1, and let's say B is 2 comma 3. And according to the question, we have PA equals to PB, because PA is the distance of the point from A and PB is the distance of the point from B. And since it is equidistant, the distance must be equal. So PA equals to PB. Now what is PA? According to our distance formula, PA then should be, we can actually do PA square and equals to PB square, so that we do not have to deal with the square root. We can directly write it. PA square is x minus 6 whole square plus y plus 1 whole square. Remember that y minus of minus 1, which is y plus 1. We are taking the difference of the y coordinates here. Again, PB squared then should be x minus 2 whole squared plus y minus 3 whole squared. Expand everything and you should get x square minus 12x plus 36 plus y square plus 2y plus 1 equals to x square minus 4x plus 4 plus y square minus 6y plus 9. And the x squares and the y squares cut off, and after simplifying everything, you can find that this equation basically gives you x minus y equals to 3, which is what the question has asked us to prove, and we are done. Okay, so yeah, the questions are not really very tough here, but you have to know how to apply your distance formulas, and it's fairly easy, I would say. Okay, so we are almost done in this part. Let's try and understand one last thing by understanding how to find the distance between 2 points in polar coordinates. So distance in polar coordinates. Okay. So let's say we have our axis here. Let's say this is the O, which is the origin, and these are our axis. And okay, let's say this is our point P, which has the coordinates in polar coordinates as r1 comma theta 1. And there is a point Q, which has coordinates r2 comma theta 2. Okay, and this is our origin. Well, of course, then OP should be equals to R1 according to polar coordinates, and OQ, where distance of the origin of Q is itself equals to R2, and we want to find this, right? Okay. Now, this whole angle should be theta 1 according to the definition, because P has an angle of theta 1 in polar coordinates, which is the angle it makes with the positive x-axis. And similarly, Q, this angle should be theta 2, correct? So if these are the angles, then angle POQ, which resides inside, which is this small angle, is nothing but theta 1 minus theta 2, correct? And if we were to apply the cosine formula now with in the angle in the triangle POQ, so the cosine formula in triangle POQ would give you the required answer, because in triangle POQ, cosine of theta 1 minus theta 2 should be equal to. So remember the cosine formula. If you're doing it on a specific angle, let's say this angle in this triangle, you simply add the sum of squares of sides that make up the angle. So you can see OQ and OP are the sides that make up this angle, and PQ is the opposite side to this angle. So you simply write OQ squared plus OP squared, and then you subtract the opposite side, squared of course, divided by 2 times again the adjacent sides, OQ into OP. This is simply the cosine formula for any angle in any triangle. Simplify it and you should get this: cos of theta 1 minus theta 2. You know the values of this. This is r1 squared, this is r2 squared, and pq squared is something what we need, pq squared, divided by, and then again this is 2 r1 r2, 2 r1 r2. Okay, we can cross multiply and get 2 r1 r2 cosine of theta 1 minus theta 2 equals to r1 square plus r2 square minus pq square. Take pq to this side and this to that side, and you can write pq is equals to the positive root of r1 square plus r2 square minus 2 r1 r2 cosine of theta 1 minus theta 2. And that is going to be the distance between 2 points with coordinates r1 and theta 1 and r2 and theta 2 in the polar coordinates where points are P and Q. Okay, so I will end this video here, and in the next video we are going to continue with centroid of a triangle and how a point can be divided into two different ratios, let's say m is to n by another point, and how a line is divided, and some basic applications and problems from previous year papers of JEE Advanced on that same topic. And after that we can move on to straight line. Okay, so I hope it was a good explanation, and if there is anything more I need to add, please let me know in the comment section. Thank you for watching.